Good morning. My name's Michael Toy. I'm with Malloy. I hope you're all enjoying. Let me see if I get this right. Deloitte's traditionally generous continental breakfast. I wish I could be enjoying a traditionally generous continental breakfast with you, but I'm going to enjoy my traditionally delicious cup of coffee. And so at Looker, we sort of took a run at the SQL problem by adding metadata layer on top of SQL that would say these computations are kind of like a new dimension in this data. And so you can think of the data as having this computation as if it were a native column, but it's actually just this SQL behind. And so now had some secret sauce computation about how we do revenue per unit or something, and encoded that in my LookML model. Then I could keep using that, and I wouldn't have to retype it in every time. And this turned out to be an incredibly powerful abstraction. I don't know that we invented a semantic model, but we certainly brought the idea of a semantic model more to the fore in LookML, and eventually, Look, a very successful company, got bought by Google. And those of us who created LookML had a chance to sort of step back without pressure to make our startup succeed anymore and think about what would we do if we could start over again. And we instantly went back to the computer language, or to the data language that underlies Looker, which is LookML, because we had reached a point where LookML, because it was basically just a thin layer on top of SQL, a good thing and a bad thing. It was a good thing is it made adoption very easy because LookML was just SQL with this very thin semantic layer on top of it, but also sort of limited where this data language could go. So we started all over again. The first thing we did to think differently is that Malloy is entirely open source. One of the problems with LookML is that it's tied into Looker, and so all of your interactions with data are sort of mediated by your relationship and how much you're willing to pay Looker, and data rates and query rates and things like that. And then the second thing that we said with Malloy is that data exploration, semantic data exploration, every time I ask a question, I'm creating a new semantic entity, and that semantic entity should be part of my next, be able to be part of my next question as well. And so in Malloy, the semantic model and the query language are the same thing. So every time you do a query, you're defining semantics for someone else to be able to use for the next query. And this was sort of our experience with LookML, is that didn't do that very well. So we designed this language, and then as we were designing a language, we on purpose didn't build Looker in it because we weren't trying to create a data application to lock people into a platform. We're trying to build a new way to think about data, which would transform all data platforms. So the history of Malloy is we designed Malloy as an open source project, and we begin to we're sitting inside Google at this time and begin to begin to integrate it into various Google pieces. There were politics, and so eventually we left Google and went to Meta, and then we were at Meta for a while, and now there's papers are being signed. We're creating a Malloy Foundation to shepherd and contain the Malloy open source effort. And so Malloy still exists, even though we're not inside Google or Meta anymore, and is still rolling, is still all of the awesome that it always was. So the state of Malloy today is that there's a core that's got a language in it that you can integrate into applications to build things out of Malloy. And there's this unique moment in time with AI that Malloy is sort of fortunately positioned really well to handle, in that Malloy is designed to reason about data the way the humans ought to think about data instead of the way SQL thinks about data. And so queries that produce this much SQL in Malloy or this much Malloy, it turns out that these things that make it really useful for humans also make it really useful for AIs, because the semantic information is right up front in a Malloy query. So an AI can read a Malloy query and understand it and summarize what's going on very easily. And as an AI writes a new query, then that makes it really easy to expand the semantic context. So we're in this unique thing where people are rethinking how they do data, and you need this intermediate layer which thinks about data at a highish level, but which can still just run queries when you need to. You end up just making way better decisions when everybody has full access to sort of the full power of data exploration. And I'm happy to be talking to a room full of people who are making that happen. And I'm really excited about Malloy as a way to do those things. So I hope you have a great day, and thanks for letting me talk to you.